Hello class, this is Ms. Peterson again. Today we're going through our 7.2 notes. We're going through inverse relations and functions. Alright, so we know a couple things here. So a relation is a set of ordered pairs, and we know given the relation we have a set of points here. We have 1, 2, 3, 4, 5, 6. We need to identify the following. So they're asking us for the domain. If you remember correctly, we know that the domain is all possible x values. They're also asking us for our range, and we know that the range is all possible y values. So looking at our set of points here, the all possible x values, we have 1, 3, and 5. So we can write this as 1, 3, and 5. And the domain of this set is we have all possible y values, so 2, 4, and 6. So 2, 4, and 6. So today we'll be talking about inverse relations. So an inverse relation is the set of ordered pairs found by reversing the x and y values. So reversing our x and y values. Given the relation 1, 2, 3, 4, 5, and 6, identify the following. If we move this down, we're looking for the inverse relation. If our original points were 1, 2, 3, 4, 5, and 6, this is our x, y, x, y, x, and y. Our inverse relation is switching our x and y values. So we'll just be switching these. So what we'll actually have is 2, 1, 4, 3, and 6, 5. Right? We just switched all our x and y values. So we have the ordered pairs of the relation here. We have a set. It's 2, 1, 5, 1, 2, negative 4, and these are the vertices of a right triangle. So finding the inverse, we're going to find the inverse of this relation and then graph the two relations. So finding the inverse of this relation, we're going to switch all our x and y values of our points and then graph it and then graph the original relation. So the inverse relation, we switch our x and y values. So we have our x, y, x and y, x and y. So switching these, we're going to have 1, 2, 1, 5, and negative 4, 2. Alright, so the first thing we're going to do is we're going to graph the original relation. So we're going to look at our ordered pairs above, and we're going to graph those. So we're going over 2, up 1, going over 5 and up 1, so 2, 3, 4, 5, up 1, and then over 2 and down 4, so 1, 2, 3, 4. So we have our right triangle here. Right? And so then if we graph the inverse relation and we look at our points down here, we have 1, 2, so we go over 1, up 2, and then we go up over 1, up 5, so 1, 2, 3, 4, 5, and then over 4, 1, 2, 3, 4, and up 2. And so this is our inverse relation, a little 90-degree triangle here, a right triangle. So notice that these are mirror images over the y equals x line. So these are, key thing about inverses, your inverse relations are reflected over the y equals x line. So these are reflected across y equals x, mirror images. Alright, so a couple other notes here. The inverse of function f of x is f to the negative 1 power x. We call it f inverse of x. If f of a equals b, and if f of our inverse b is equal to a. So the first thing we're going to do is find the inverse of f of x equaling x plus 2. So what we're going to do is we're going to switch f of x with x and then solve for f inverse of x. That's easier seen. So if we have f of x equals x plus 2, we're going to switch our x value and our f of x value. So we're now going to have, this is going to move over here, this will move over here. So we have x is equal to f of x plus 2. But because we're trying to find the inverse, we're going to name this f of x f inverse of x. And from here, we're going to solve for our f inverse of x. So to get our f inverse of x alone, we're going to subtract 2 from both sides. So we'll have x minus 2 is equal to f inverse of x. This is more commonly written as f inverse of x is equal to x minus 2. And that's our inverse. All right. So for our next example, we have evaluate f of 5 and then evaluate f inverse of 7. So our f of x is equal to x plus 2. We knew that from up above. So f of 5, we're plugging 5 in for x, so f of 5 is 5 plus 2, which is equal to 7. Right? And we found that our f inverse of x is equal to, from up here, x minus 2. So f inverse of 7 is equal to, we're plugging 7 in for our x value, so 7 minus 2. 7 minus 2 is equal to 5. Right? Notice how f of a is equal to b, f of a is equal to b, and then f inverse of b is equal to a. We really just switched our 5 and 7 around. We'll do one example together. So we're finding the inverse of f of x equals x plus 6 over 2. So we're going to switch our x and f of x values, and then we'll solve for f inverse of x. So rewriting our problem, we have f of x is equal to x plus 6 over 2. The first thing we're going to do is switch our f of x and our x. So now we have x is equal to f of x plus 6 all over 2. And this is the inverse, so this is really f inverse of x. So solving for our f inverse of x, we need to get this 2 off the bottom, so we multiply by 2 on both sides. So that gives us 2x is equal to f inverse of x plus 6. Getting this f inverse of x alone, we subtract 6 from both sides. So we have 2x minus 6 is equal to f inverse of x, in which we would write as f inverse of x is equal to 2x minus 6. And I think that'll be our last problem for today. We'll go through the rest together in class. Don't forget to take your Schoology quiz, and I'll see you tomorrow.